Okay, quadratic formula. So quadratic formula is important because it is one of the two methods of solving quadratics that always works. So this is why, factoring problems, this is why we need to do it here. Factoring problems are actually really special combinations of numbers. Factoring is quicker, I think, in most cases, and so that's why we focus on it so much. But quadratic formula works no matter what. So quadratic formula, opposite of b plus minus square root b squared minus 4ac, all divided by 2a. So there is your quadratic formula. Mr. Graham or Ms. Aldrich, maybe they sang that to you. I'm not going to sing that to you on this video because the internet is full of it. But I will work these problems for you. So this first problem, we have A is 1, B is -6, and C is positive 13. 13 is at C, that's what makes this guy not factorable. 13 is a prime number there. So I'm going to plug in and then I'm going to trudge through the math. Opposite of B, my B is -6, so the opposite of it is positive 6. There's my A and my C. Notice this big divided by, that's probably the biggest thing that I see students struggle with, is where that division sign is. That whole thing is your numerator. Okay, next step. The precision is a little bit of a struggle here. -6 squared, negative squared is positive, 6 squared is 36. Sorry about that. And so we have 6 squared is 36, 4 times 3 is 52. 2 in the denominator. And then we need to do 36 minus 52. Those are 16 apart. It's going to give us -16 there. And now we're going to deal with a radical. So the square root of -1, if you want to think of it like this, I like to think of this as -1 and 16. So the square root of -1 is I, square root of 16 is 4. And then to get this fully simplified, you can think of this in one of two ways. I like both. But you need, if you're going to divide by 2, you need to divide by 2 both places. So you can either think of it as breaking up the fraction over the common denominator. I kind of dig that. Or you can think, basically what you need to do is really factor out that 2. So when you factor out the 2 from the numerator, 3 is left and 2i is left. So these are the ways that it's legal to break that up. So here you would cancel the 2's. Here you would divide and get to that same answer of 3 plus n minus 2i as your final answer. The danger here is this. Don't do 6 divided by 2 is 3 and then have that 4i left, because 3 plus or minus 4i is not the correct answer. You need to train yourself to take that 2 from both terms up top. If that's not something you're making a mistake on, then you can disregard that whole explanation. If it is, pick the way you like, either breaking it up into 2 fractions or factoring. Remember, canceling is just division. So the only thing we can undo by canceling is multiplication. So that's the idea behind factoring that out first. Okay. Another quadratic formula problem. Our A is 10, our B is positive 6 this time, and our C is 1. So opposite of B is going to be a -6. There's 4AC. And our A this time is 10, not a 1. All right. Now let's trudge through the multiplication and subtraction. 6 squared is 36. 4 times 10 is 40. 2 times 10 is 20. This one's not quite as bad as the last one. Not that it was terrible, but 4 times 13 takes a little more brain power than this one. 36 minus 40 is negative 4. Again, I'm going to think about the square root like this. Square root of negative 1 is I. Square root of 4 is 2. And then we can factor out a 2 from the top if you like thinking about it that way. You can also break it up like we did with this other one and reduce your fractions. Here, 2 over 20 is going to give us a 10 in the denominator. So our final answer is negative 3 plus or minus I over 10. All right, there's your quadratic formula section.